Hi, third grade students. This is Ms. Padilla, and today I'm going to be teaching you about equivalent fractions. Okay, ready? Okay. So if we had a fraction of 1/4, well, before we even draw a picture of 1/4, let's identify what each piece of the fraction is so we know exactly what we're drawing. 4 is the denominator or the bottom number. That shows you into how many pieces the fraction is broken up into. For this fraction, I know that it's going to be broken up into 4 equal pieces. The top number is the numerator. The numerator tells me how many of those pieces are shaded in. In this fraction, 1 is shaded in. To make an equivalent fraction, we want to make a fraction that is the same amount of space shaded in. So for example, an equivalent fraction to 1/4 could be 2/8. To show this in a picture, instead of cutting our fraction into 4 pieces, we'll cut our fraction into 8 pieces. Now, instead of shading one piece in, we'll shade 2 pieces in because the numerator is 2. If you look closely to these pictures, or you can imagine them on top of each other, you'll see that they take up the exact same amount of space. The same is true when you look at fraction bars. We're just looking for fractions that might have different numbers but take up the same amount of space. Let's read the directions on this worksheet. Use the fraction models to complete the statements below. Circle the correct numerator. Let's look at our first example, 1/4 and blank 12ths. We know that 12 is the denominator here as 1/4. So that means that in the first part, there are a total of 4 pieces, and because 1 is the numerator, there is 1 piece shaded in. In our second fraction, we know that there's 12 pieces in total because 12 is our denominator. But what is the numerator? Let's count the shaded in pieces to find out. 1, 2, 3. 3 bars are shaded in. So I think 3 is the correct numerator. Let's circle 3, and if we look closely, we'll see 3/12 takes up the exact same amount of spaces as 1/4. That's what we're looking for in equivalent fractions. So 3 is the correct numerator. In the second example, 2/3, for example, is equivalent to blank 9. Again, in our first fraction, 3 is the denominator because there are 3 pieces in total. 2 is the numerator because there are 2 pieces that are shaded in. In our second fraction, we're going to count the shaded in pieces to see what the correct numerator is to make an equivalent fraction with 9. Okay, so there are 6 pieces shaded in, which means 6 is the correct numerator. 2/3 is equivalent to 6/9, and we can see that 2/3 and 6/9 take up the exact same amount of space, so 6 must be the correct numerator. Let's take a look at our last problem. Our first fraction is 4/8, and our second fraction is blank 16th. Let's identify the numerator and denominator in the first fraction. In the first fraction, the numerator is 4. That means there are 4 pieces shaded in. The numerator is always the top number, and the bottom number is our denominator, and that tells us how many pieces there are in total, and in total, there are 8 pieces in our first fraction. In our second fraction, there are 16 pieces, right? In total. But what's the numerator? Well, let's count the boxes to find out how many 16s need to be shaded in to make it equivalent to 4/8. Well, there's 8 pieces shaded in, right? And if we look, it takes up the exact same amount of space as 4/8. And that means that 8/16 is the equivalent fraction, meaning that 8 is the correct numerator or top number. Okay? So, thank you for watching, boys and girls. Remember always that the numerator is the top number, and that shows you how many pieces are shaded in the fraction. And the bottom number is the denominator, and that shows you how many pieces are in total.